Now my dear students, we can go to the question number 31. A first order reaction has a rate constant. So here you get the values k is equal to 2.303 into 10 to the power minus 3 and time required for 40 gram. T calculate. A is equal to 40 gram of this reactant to reduce 10 gram means A minus X that equal to 10 gram. So here my dear students, you can see here that is K is equal to 2.303 upon T log A upon A minus X. Here that equal to K is equal to 2.303 and K values of K is this one. So you can put the values of K and here you can put the T. T is equal to 2.303 into 10 to the power minus 3 log A for 40 gram, A minus X is equal to 10 gram. Now my dear students, you can get the log 4 and here this is a cancel by 1. So T is equal to here 1 into 10 to the power minus 3 into log 4. My dear students, log 4 values, log 4 is equal to that is 0.602. So you can this 0.602 is here this is T is equal to 0.602 upon here 10 to the minus 3 means 10 to the power 3. So this 0.123 these are cancelled with each other and you can get the 602 second. So my dear students, 602 is the correct answer for this question. Question number 31, you can put the formula. My dear students, it's a first order reaction formula, na? You know very well. This is the first order reaction formula and we can use this first order reaction formula. So answer is D, question number 31. We have verified. Now we can go to the question number 32. Here my dear students, question number 32, the correct difference between first and second order reaction is that. Here 32 you can see the difference, correct difference between the first and second order reactions. Difference of first and second order reaction, my dear students, you can see the half of the first order reaction does not depend on a 0. Means you know the half of the reaction, half life. My dear students, when you can calculate the half life, then what is the formula of half life? I give you concept and trick and formula, okay, concept and trick. My dear students, you can get the trick. Half life is equal to 1 upon initial concentration of n minus 1. You can use this formula for determine the relationship between the half life and initial concentration of the reactant. Here T half, it is a half life. Here my dear students, A is the initial concentration of reactants and N is the order of reaction. Here you can see the difference between first and second order reaction means when you can see the N is equal to 1, you can N is equal to 1 and you can get the half life relation between initial concentration. So N is equal to 1, T half is inversely proportional to A ki power 1 minus 1, it means T half A ki power 0 and any power 0 it means it is a 1. So here my dear students, we can see the N is equal to 1. We can see the N is equal to 1. Here you can see the for the first order of reaction, N is equal to 1. It is not depends on initial concentration. In first order of reaction, half life is not depends on initial concentration. Now we can put the N is equal to 2 because in numerical in this question difference for half life second order reaction. So, n is equal to 2. Then my dear students, you can take it T half is inversely proportional to a ki power 2 minus 1, that is a ki power a inversely proportional. So, you can write here in second order reaction half life is inversely proportional to the initial concentration of the reactant. So, my dear students, here you can see the question number 32B option does not depend on the initial concentration is 0, and the half life of a second order reaction does depends on a 0, means it is inversely proportional. So, this is the difference, and you can find out the, it is a very important formula for you. T half is inversely proportional to a ki power n minus 1. Now, my dear students, we can go to the question number 33. When initial concentration of the reactant is doubled, the half life period of a zero order reaction. Here we can see the T half. I can give you a relationship between T half and initial concentration. Here that is for zero order reaction 0 minus 1, that equal to a minus 1, means it is a T half is proportional to a. It means T half is proportional to initial concentration in zero order reaction. In any reaction, my dear students, in any reaction when you can get this type of questions, you can remember this formula and put the order of reaction in n, in place of n, and get the answer. So, my dear students, when initial concentration of the reactant is doubled, the half life period of the zero order reaction is also doubled. So, question number 33, you can go option B. This question is also come in NEET 2018. My dear students, you can solve various type of questions in which order of reaction is given, but you can remember this formula only. Now, we can go to the question number 34. A first order reaction has a specific reaction rate of 10 to the power minus 2 seconds. How much time will it take for 20 gram of the reactant to reduce 5 gram? Here in this question, K is equal to specific reaction rate, first order reaction. Specific reaction rate, it means it is a rate of reaction, and here it is a rate of reaction R. R is equal to 10 to the power minus 2. How much time, he want the time, how much time T will it take 20 gram of the reactant, this initial concentration 20 gram, to the reduced to, means A minus X is equal to 5 gram. Here, my dear students, you can see here in this formula, this A first order has a specific reaction rate constant. It is a constant, my dear students, reaction rate constant. So, because he want the time, so K must be there for the calculation of time, because it is a first order reaction. So, we can use the formula of first order reaction. K is equal to 2.303 upon T log A upon A minus X, that is equal to 2.303 upon T log initial concentration is 20, and after time T you get the concentration of 5. So, my dear students, K is equal to 10 to the power minus 2 you can take here, and this 10 to the power minus 2 is equal to 2.303 upon T log 5 4s are 20. So, you can here take the 4. Now, my dear students, 10 to the power T is go here, 10 to, so you can write here this T is equal to 2.303 upon 10 to the power minus 2, and log 4, my dear students, log 4 is equal to 0.602 you can put the values of 0.602 here. And my dear students, when you solve this question and you can get the answer, that is t is equal to 138.6 seconds. You solve this 10 to the minus 2, you can multiply this 3 and 3 cancelled with each other, divided, and you can get this answer 138.6. And now we can go to the answer A, option A, question number 34. Now my dear students, we can see the question number 35. Here this question is also called in NEET 2016. Here the rate of first order reaction is 0.04 mole per liter at 10 seconds, means the rate of reaction, and here time. Here 0.04 mole per liter at 10 seconds, and here 0.034 mole for 20 seconds. And what is the half-life period of the reaction? Here my dear students, you can get the two type of rates. So you can use this formula k barabar 2.303. Here for time you can write here T2 minus T1, log here concentration R1 upon R2, you can write here R1 upon R2. So my dear students, 2.303 upon T2 minus T1 means 20 minus 10, here log R1, that is equal to 0.04 upon 0.03. Here that is the k, my dear students, you can solve it 2.303 upon 10 log, here log 4 by 3, and you can calculate this k, my dear students. Here log 4 by 3 you can log 4 by 3, or you can also get is equal to log 1.33. Log 1.33 or log 4.3, that is equal to, my dear students, 0.2303. This is the values of log 1.3. Because my dear students, log 2 is equal to 0.303. So value is lower than 0.3, that is a 0.2303. So you can put here values, k is equal to 2.303 upon 10 into log this 1.33, and you can put the values k is equal to 2.303 upon 10, and this is the log 1.3, and log 1.3 you can put the log 1.3, that is equal to 0.12. My dear students, log 1.33, that is equal to 0.12. You can see here it is a 0.12, because log 2 is equal to 0.303. So here log 1.3 log 0.12, less than log 2. This 1.33 is lesser than log 2. So my dear students, you can get here 0.12. Then my dear students, this is 2.30 upon 2, and you can get this value is equal to, when you can multiply all the values, you can get 0.028 values of k. And my dear students, in question you can see here, he has the half-life period, and half-life period for the first order reaction. Now we can get the half-life period of the first order reaction. Formula is this one. You can calculate the half-life period in this side. T half is equal to 0.693 upon k. When you can put the formula by these reactions, and this formula you can use, you can get the values of k, and that is the 0.08. So you can 0.693 is divided by 0.028. So my dear students, T half is equal to 24.1 second you can get. When you can divide this, then you can get 24.1 second. So my dear students, question number 35, you go to the answer C. C is the correct answer. Now this question is also asked in NEET 2016, my dear students. First of all, we can calculate this K, and after K we can put this formula half-life. For first order reaction, my dear students, this is the half-life. This formula is very important for first order reaction. We can use this formula, first order reaction. Now we can go to the question number 36. Here, my dear students, when initial concentration of reactant is doubled in a reaction, its half-life period is not affected. The order of reaction is, my dear students, you can see in previous question, question number 35, T half is equal to 0.693 upon K. And my dear students, this is the formula for first order reaction. My dear students, you can see the concept. In first order reaction, you can see the K is equal to 2.303 upon here T half log A upon A minus X. Half-life period means initial concentration is just half. So, my dear students, initial concentration 2.303 upon T half log A upon A by 2. So, my dear students, you can see here, this is a T half log 2A upon A. So, you can cancel it and you can get that 2.303, and log 2, my dear students, that equal to 0.3010. So, you can put here values 0.3010 upon this is a T half. You can see here initial concentration are cancelled with each other. So, you can get, my dear students, that is the 0.693 upon T half, that equal to K. So, my dear students, this formula is used in first order reaction. So, first order reaction, when initial concentration of the reactant is doubled, its half-life period is not affected because here initial concentration is not present in this formula. So, my dear students, order of reaction is always first order. Question number 36, answer is D, first order. Now, my dear students, we can go to the question number 37. Here you can see the 37 question. A reaction is 50% complete in 2 hours, means half-life period is 2 hours for this reaction. Now, my dear students, when this is the half-life period, you can see the another formula, that is T 75%, that equal to, my dear students, 2 into, because this is the half-life, 2 into T half, and you can get the concentration T 75%. Now, my dear students, you can see here time, half-life time is that is a 2, here 2 hours into 2 means for T 75% is complete, that equal to, he take the 4 hours. So, my dear students, what is the order of reaction? Simply this is the order of reaction first, because in this first order of reaction this formula is used for first order of reaction. Order of reaction, we can use this formula. So, my dear students, question number 37, you can go the option A first. Now, we can see the question number 38, my dear students. Here question number 38, my dear students, you can see the half-life of a substance in a certain enzyme catalysis is 138 second. 138 second, this is the half-life of certain compounds. The time required for the concentration of the substance to fall from 1.28 milligram to 0.04 milligram. My dear students, our formula is time required, that equal to number of half-lives, because in this question he want the time required. So, you can see here time required for, that is the number of half-lives, into, my dear friends, T half. This formula is used. You can calculate the half-life by this. Here 1.28 milligram number of half-life you can calculate, because you can See here initial concentration 1.28 and concentration up to 0.04. When 1.2 is divided by half, first half life you can get, and my dear students 1.28 divided by 2, you can get the 0.64. Now my dear students, then second half you can divide by 2, you can get 0.32. Now my dear students, it is divided by 2, you can get, this is called third half life. Then you can see here here half divided by 2, 0.16. Now my dear students, when you can divide it by this half 0.16, you can get the fourth half life, then you can get the 0.08. My dear students, when this is divided by next half life, then you can get the fifth half life 0.04. And here in this question, my dear students, he want the 1.28 milligram convert to 0.04 milligram. So my dear students, here you can see the 5 half lives are used, and 5 half lives are used. What are the time required into what is the half life? Catalyst reaction, that is the half life is the 138 second. It is given in your question. So my dear students, when 138 multiply by the 5, then my dear students, you can get the 690 second, and you go the question number 38 option C, because this 690 second present, so you can go the option C. Now my dear students, when you can see the question number 39, in 39 my dear students, half life period of first order reaction is this, and the specific means simple question. First order reaction formula is K is equal to 0.693 upon T half, and here he want the half life period. So my dear students, you can see the T half is equal to 0.693 upon K. Then simply you can put the values of half life period of first order reaction, means 1386, you can put the values here in formula 1, 0.693 upon 1386, then you can calculate this. Here point is replaced by this 303, and this is the divided, and you can get the 5 into 10 to the power minus 2 per second. So my dear students, you can solve this question by this formula. You can use this formula, put the values are given in your question, and get the answer 5 into 10 to the minus 2 second. Question number 39. Question number 39, you can, here you can see the 10 to the minus 2 and 10 to the minus 3. So my dear students, you can get the answer. When you solve, you can get this answer is 0.5 into 10 to the minus 3, 0.5 into 10 to the power minus 3, or you can say this is the 5 into 10 to the power minus 4, and here you can see the 5 into 10 minus 2. So here you can see the 5 into 10 minus 4. Okay, when you solve this question. Now this question is easily solved. 693 divided by here you can 693 divided by 1386 into 10 to the power 123, you have 10 to the minus 3. So this is not answer 10 to the minus 2, 10 to the minus 3, but here point is given to get the 0, 1 0, 2 0 is given. So here 0.05 10 to the minus 3. So you can get the 0.5 into 10 to the minus 3. You can get here 6930. Then you can get 6930. So my dear students, this is divided by 5. So 6930 you can get the, so 0.5 into 10 to the power minus 3. When 1386 multiply 5, you can get 6930. So 0.5 into 10 to minus 3, because you put the 10, so 0.5 into 10 to minus 3 is the answer. In this way you can calculate, simply calculations there. Now we can go to the question number 40, here 40 and here 40. This 60% of a first order action was completed to 60 minutes. Oh, and 50% of the same reaction would be completed. My dear students, when here 50% is the given, means this is the T half is apply. Okay. So first of all 60% complete in 60 minutes. You can solve the K. First of all, you can calculate the K. K is equal to 2.303 upon T log A upon A minus X. Here 60% means A is equal to 60, A is equal to 100 and A minus X, that equal to 100 minus 60, and time T, you can get the T, that equal to 60 minutes. So you can put the values 2.303 upon, that is time is 60, log here 100 upon 100 minus 60, means you can get the log 40, K is equal to 2.303 upon 60 log 100 upon 40, log 100 upon 40. It means this is the log 10 upon 4, log 10 upon 4. And my dear students, you can see the log 10 upon 4 means log 2.5. 10 upon 4 means that is 2.5. So log 2 is equal to 0.3010 and 0.5 is extra, means you can get the more than 0.3010. So my dear students, you can get the log 2.5, that equal to 0.397. You can get this value 0.397. So you can put the 397, K is equal to 2.303 into 0.397 and divided by 60. Now we can get the 0.0153, my dear students. When you can divide and multiply, you can get the value of K. But here you can see 50% of the same reaction would be completed. It means half life. You can put this K in half life, then you can get the answer. Here T half, that equal to 0.693 upon K. My dear students, you can put the 0.693 upon 0.0153, then you can get the this multiply of this and get the T half, because here 50% is complete. So here he want the T half. So T half, my dear students, that is, you can see here T half, that is the 45 minutes, 45 point something, or you can say here that is the 45 minutes. So my dear students, you can get here 45 minutes. It is the answer, question number 40, answer is A. And what is the answer, my dear students? That is the 45 minutes. First of all, you can apply the formula, and this formula is the K is equal to this 2.303 upon A minus X, and find out this K, and after the values of K you can determine, then you can put the values of K here half life period, because here 50% of the same reaction. So it is a half life. Log 4 is also given 0.60, log 5 is also given, that is 0.69. So you can also use these logs and get the answer. Here, my dear students, we can see the question number 41. In a first order reaction A to B, if K is a rate constant and initial concentration of the reactant A is 0.5 molar, then the half life is, my dear students, here we can put the formula K is equal to 2.303 upon T log A upon A minus X. Here my dear students, if you can take this initial concentration is just half, means you can see the half-life period, what is the half-life period of this concentration, and here you can see 2.303 is not present, here ln is also present. So, you can also write this 1 upon T ln A upon A minus x. When my dear students 1 upon T ln, first of all initial concentration is just half after time t, so it is called half-life T half. My dear students, it is a 2a, it is also called 2a, 1 upon T half ln 2a upon A, so ln 2. So, you can see here k is equal to ln 2 upon k. My dear students, it is the formula for half-life period, and you can say here question number 41 you can get the answer C. So, my dear students, if you get the answer C, question number 41, then we can see here question number 42. Here question number 42, my dear students, for the first order reaction A to give B, the reaction rate at reactant concentration of 0.01 molar is found to be 2 into 10 to the power minus 5 mole per liter. The half-life period of the reaction is. Here my dear students, you can see here that is the first order reaction rate at reactant concentration 0.01 molar is found to be this, and you can calculate that this rate is equal to K into concentration to the power A. This is the formula number 1, and you can find out the K from this concentration. And when my dear students, you can find out the K because here rate is given, that is 2 into 10 to the power minus 5. Here K into concentration is given, that is 0.01. So, my dear students, K is equal to 2 into 10 to the power minus 5 divided by that 0.01. Here you can see this 2 into 10 to the power minus 2 into 10 to the power 2 upon this is 10 to the power 5. So, my dear students, you can get here 10 to the power 3. So, you can call it 2 into 10 to the power minus 3. This is the values of K for question number 42. Now, my dear students, here in this question half-life period of the reaction he want. What is the formula here? Formula number 2, T half that equal to 0.693 upon K, and this is the formula number 2. You can put the values of K here and you can get the answer. T half is equal to 0.693 upon 2 into 10 to the power minus 3. When my dear students, you can put the 2 into 10 to the minus 3 and divide this 0.3 and this 693 divided by 2. It means 693 divided by 2, because these are cancelled with each other. 10 to the minus 3 go to up and it is down. So, my dear students, here these are cancelled with each other. These are 10 to the power 3 are cancelled with each other, and you can get the 693 upon 2, and these are cancelled. 3 to the 6, 3 4 the 8, 13, and 3 7 the 7 to the 14. So, my dear students, you can get the answers D. Here 3 to the 6, here 3 4 the 8, 1 13, you get 13, 693. So, my dear students, 7 4 the 7 to the 14, 346 point something you can get, means you can get the 346.5, and it is approximately to 347, because 7 to the 14 and you get here 13. So, you can get 346.5, or you can whole number 347, because 346.5 is not answer in 4 option. So, my dear students, you can get the answer, and our answer is a 347. Now, we can go to the question number 43. Here, my dear students, question number 43, you can see here the rate of a first order reaction is K is equal to rate of first order reaction rate. Here you can see the rate to R. It is the same, R is equal to K into A. Same question 2004 NEET exam, he is asked NEET 2004. Question is the same, R is equal to K, but value is different. R that equal to 1.5 into 10 to the power minus 2, value is different. So, calculation is there 0.5. Here you can write K is equal to 1.5 into 10 to the power minus 2 divided by 0.5. Point cancel. 5 3s are 15. You can here get the 5 into 10 to the power minus 2, k is equal to. Now we can, he want the half life. Now we can use the half life. This is our first formula for rate of reaction of first order reaction, and second formula is T half, that equal to 0.693 upon k. Then you can put the values. 0.693 upon 5 into 10 to the power minus 2. Then my dear students, you can get the answer is 0.3. Here you can get the answer. Your answer is, my dear students, that is 23.1, and this answer is present in, that is A, B, B. B is the correct answer, my dear students. When you this 0.3, when you this multiply here, you can get the this 10 to the power 3. They cancel with each other and you get the 10 to the power 1. Then 693 divided by 5, and when this 693 divided by 5, then my dear students, here 0.5, yes, here you can see here 3 into 10 to the power minus 2 you can get. So you can not write here 5, you can, my dear students, you can write 3. Here we can write here 3. So not 5, here we can write 3 because we can get 3 here. So here, my dear students, we can write here 3, this 3, and when this 3 is divided by 693 upon 30, because 10 to the power 1 is plus 1 is present here. So it is a 30. So you can go get the 23.1. This is answer. Now my dear students, we can use this to solve this question. We can use the two formulas. Number 1 is the rate of reaction and number 2 is the half life. Now we can go to the question number 44. In question number 44, my dear students, A to give B, follow first order kinetics. The time taken for 0.8 mole of A, you can here A, you can case 1 and case 2, here A and B. My dear students, you can see here 0.8 mole of the A to product B, and that B is present at 0.6 mole, and time taken is, that is T is equal to, here T is equal to 1 hour. My dear students, what is the time taken for conversion of 0.9 mole of A to produce 0.67 mole of B? Here when you can see the 0.9 mole of A and convert into, this is a 0.9 mole of A and convert into B, that is the 0.675. Now my dear students, you can see here case 1 is, this is the case 1 here and this is the case 2, and he want the time. You can see the concentration difference. Here you can see the concentration difference. Here 0.8 concentration and rest of concentration is 0.6. Here you can see the 0.2 concentration is remaining present in A. Here when you can see the initial concentration 0.9 and here B is present 0.6, means here, my dear students, you can get the concentration, that is 0.22 is remaining. It means concentration is remaining is same, concentration of B is obtained same. So my dear students, time is taken is same. Time is taken is same. So answer is 1 hour. So you can go the question number 44A. You cannot calculate this question, this type of question. Only concept is there, my dear students. If you know this type of concept, then you can easily solve this type of questions. This question is also asked in 2000 NEET exams. Now my dear students, we can go to the question number 45. Here we can see for a first order reaction, the half life period is independent of initial concentration. Theoretical question, and I already given you relationship between the half life period and initial concentration for first order reaction. Here my dear students, in this question, in this formula, initial concentration is not present. So in first order reaction, you always remember this, in first order reaction, half life is not depend on initial concentration. So now my dear students, in this chapter chemical kinetics, I give you lot of examples and tricks and formulas. All formulas I am giving you. and by this formula, by this trick, you can easily solve the problems which are coming in your exams. Thank you very much.